So differentiation using limits of difference quotient. Again, from the previous section, recall that the difference quotient f of x plus h minus f of x over h. This is, we called it the average rate of change. And if you look back at the figure I showed you in the previous section, this actually represents the slope of the secant line. It's called the slope of the secant line, connecting the points x f of x and x plus h comma f of x plus h. I'm going to redraw the same figure from before. This is the function f, and these are the 2 points, let's say. This line is the secant line. This is x plus h. How are we going to use this difference quotient, and for what? Why are we learning this? Again, this represents the slope of the secant line connecting these 2 points. This was a distance h from here to here. What happens if I make h smaller and smaller? Smaller and smaller means make h get closer to 0 in value. So what happens as h gets closer to 0, limit-wise? So I'm using these terms, assuming you guys already went over the sections from last week, including the limits. What happens if h goes to 0? If h goes to 0, this point here will get close down and down and down, right? Because it will move as it gets closer and closer. And eventually, this point will become here. So that line, the secant line, is going to look like this. Right? So then the secant line, so this is secant line. What does it become? It becomes a tangent line. It's the line that touches the graph at exactly 1 point. That's called tangent line. So if I want to represent this in a different way, we say the limit of the difference quotient as h approaches 0 represents the slope of the tangent line at the point x1 f of x1. So in this case, let's call this x1. So at that point, so it's the slope of the tangent line, and we call it the instantaneous rate of change. Instantaneous rate of change. And to apply this, we let f of x be x squared plus x plus 1 Find the instantaneous rate of change at x equals 2. So there are two ways to approach this. The instantaneous rate of change we define as the limit as h goes to 0 of f of x plus h minus f of x over h. So you can find this whole difference quotient as we did in the previous section, and then pass the limit at the end. Or what you can do before you find what that is, you can replace, it's given x is 2 plus h minus f of 2, just replace every x with 2. We need to find f of 2 plus h. We can do that on the side. That's what I like to do. It's easier this way. Replace every x in the function with 2 plus h. This one is 4 plus 4h plus h squared plus 3 plus h. That gives us 7 plus 5h plus h squared. So we're going to find the limit as h goes to 0. 2 plus h. We found it. It was 7 plus 5h plus h squared minus f of 2. Replace x with 2. 2 squared plus 2 plus 1. Let's simplify. 7 plus 5h plus h squared minus, this is 4 plus 2 6 plus 1 7 over h. Notice how the 7 cancel each other. On the top we can factor an h out. H cancel. If you pass the limit as h goes to 0, that gives us 5. That's the slope of the tangent line at x equals 2. How about find the equation of the tangent line to the graph of y equals f of x 1 over x at x equals 1. So to find the equation, remember the equation of the line, the formula y minus y1 m times x minus x1. That's the formula. So you need a point and a slope. I only have x1. I only have the x. If you substitute x equals 1, you got the y value 1. So the point is 1, 1. That's x1, y1. So I have that set. What is m? Well, m is the slope of the tangent line. How do you find the slope of the tangent line? Well, in this case, m of the tangent line, we defined it as the limit as h goes to 0 of f of x plus h minus f of x over h. So we're gonna find f of 1 plus h minus f of 1 all over h. So again, f of x is 1 over x. I want to find f of 1 plus h. That's simply 1 over 1 plus h. Nothing else can be done. 1 over 1 plus h. F of 1 is 1 over 1, all over h. The LCD, what would be the LCD here is simply 1 times 1 times 1 plus h. It's just 1 plus h. So you multiply the numerator of each fraction by 1 plus h. That's the easiest way to clean up the complex fractions. Limit as h goes to 0. These cancel each other. 1 minus 1 times 1 plus h. Always denominator stays the same. Limit as h goes to 0. On the top, 1 minus 1 minus h. These cancel and the h cancel. So the only thing left is to pass the limit, negative 1 over 1 plus 0. That's the slope. We have the slope and we have the point 1, 1. So from the formula, y minus y1 m times x minus x1, this is 1, the slope is negative 1, and this is 1. Keep this the same, multiply the negative in, then add 1 to both sides. Note, the limit as h goes to 0 of fx plus h minus f of x all over h. This is called f prime of x. So it's read as f prime of x. It's a simple. What is that simple for? This is for what we call a derivative of the function f of x. Derivative of f of x. So if they ask you, we're asked to find f prime of x and f prime of negative 3 for the function 3/2 x squared. So how do we do that? So to find the first derivative, or f prime of x, we define as the limit as h goes to 0 of f of x plus h minus f of x all over h. F of x plus h. Replace the x with x plus h in the function, minus the function itself all over h. While you're writing this down, keep the limit as h goes to 0 as is. 3/2. Let's see what we get here. X squared plus 2xh plus h squared. Now look what we can do here to make this easier. I see 2 in the denominator here, here, and there's a 1. So the LCD is 2. Multiply by 2 each, the top of each one of them. And that will give us 3x squared plus 6xh plus 3h squared minus 3x squared all over 2h. These cancel out. To finish this up, we factor an h out. 6x plus 3h over 2h. The h cancel out. As h goes to 0, you get 6x plus 0 over 2. That's 3x. That's f prime of x. Later on, you will learn shortcut. With one step, you'll be able to find this. The other part of the problem is asking us to find f prime at 3. Was it? Negative 3. So all we have to do is just replace what we get with the 3x, 3 with negative 3. So that's a negative 9. This number here we got is really the slope of the tangent line. To the graph of f of x at x equals negative 3. Differentiability. What is differentiability? We want to examine if a function is differentiable or not. We want to examine if a function is differentiable or not. So we say a function is differentiable when its derivative is defined at all points. Is defined at all points. And I'll show you what that means. Like sometimes you find the derivative of the function, but then when you substitute a value for x in, it might be undefined. Like, for example, dividing by 0, for example. That makes it undefined. So in general, a function is not differentiable. Where does it fail to be differentiable? When, part A, whatever it's discontinuous. Wherever it's discontinuous. Another place at the corners. We call them cusps. And the last one at the vertical tangents. So let's look at this case. This is the graph of f at x equals a. Such a function, this is not differentiable. F is not differentiable at x equals a, since it is discontinuous. At that point, right? It's discontinuous at that point. From previous sections, you should know what continuity means. There's no gaps, no jumps, no holes. So since it's not continuous at x equals a, means it's not differentiable at that point. That's about an example about discontinuity. Another example. At these points, it's not differentiable. At these points, not differentiable. Graphically, not differentiable, because those are corner points. Those are corners. An actual example would be y equals absolute value of x. This function. Right? So this function is not differentiable at the origin, at x equals 0. The origin.
Professor,
Yes.
at any other point on the graph, would it be differentiable?
Yes. On any other point is fine. So other cases, say you have this graph. There's a tangent, vertical tangent. So this is vertical tangent. At that point, the vertical tangent is not differentiable. So this is the function f. Not differentiable because at that point it fails to work out, because vertical lines have undefined slopes. Not differentiable. For an example, like an algebraic example, for f of x, the one we worked with earlier, if you happen to find the derivative of that using the limit as h goes to 0 and the difference quotient, this will reduce down to -1 over x squared. And you can try it. This one, which is not differentiable, at x equals whatever that is, x equals 0 here. It's not defined and hence not differentiable at x equals 0. I'm gonna draw one last example. So we have this graph. I'll give you time to copy it down. So where is this function not differentiable? What is it not differentiable? First thing, at x equals e, call it f, this function f. F is discontinuous and hence not differentiable. Also, it is not differentiable at x equals what? A, B, C, D, F, G, and H because of the corner points. Because of the corner points.